Hi, my name is Savannah Lennon, and this is my Week 7 review of the videos for Physics 2211. The main physics ideas of this week are the energy principle, work, incorporating both of those concepts into the same problems, and work by non-constant forces. And to go a little bit more in depth on each of these topics, the energy principle is a new fundamental principle in addition to Newton's second law, and is very important to examine any energy changes. So the total system energy is denoted by the symbol E, and is basically just all of the different types of energy summed up. And changes in E only occur through energy transfers via the surroundings. So basically the core ideas of the energy principle are that energy in a system describes physical quantities and properties, and in the surroundings, it describes the interactions. And energy is also scalar. Going off of this, work depends on the magnitude of both force and the displacement, so delta R. And you could, if they're going in the same direction, you can use the formula magnitude of F times magnitude of delta R, and that would be sufficient. But if the force is occurring at an angle different than that of the displacement, then you have to include cosine theta in order to get the correct calculation. And work has the same dimensions as energy, which is the joule. And this denotes change in energy. Some new information I learned this week was the energy principle as another fundamental principle, and work itself. I wasn't sure how to calculate this before, and previously learned information was that of kinetic energy, but in very basic terms. So something I found really interesting was the way that energy transfer can be connected through many different pathways, and that there are so many different ways that energy can be transferred, and many different things that indicate energy transfer that I just didn't even realize were a thing. And it could relate to the neuroscience field in that neurons must transfer energy in order to generate action potentials, and that's how you sense things or even move at all, kind of do anything, process anything. And also, in order for cells to grow, mutate, change, you also have to have energy transfer. Overall, I didn't find any of the topics too confusing or difficult. I think the videos did a really good job of explaining the concepts, and there was a whole video dedicated just to two example problems using work and the energy principle. And they did a very good job of going into depth of that. They did state in this the steps that you should use to tackle these problems, which are identify the system, including initial and final states. Then you identify agents that are interacting with the system, because these could contribute to energy transfer. You then write out the energy principle, which is delta E equals W in detail, according to the givens you have in the problem. And then finally you solve for unknowns. They also go into detail, now that there are two fundamental principles, Newton's second law and the energy principle, how to choose which principle to use to tackle a problem. And basically, if you have a displacement, then you should start with the energy principle. And if you have a specific change in time, you should start with Newton's second law. And in addition to this, if you have a scalar unknown, you should use the energy principle, because that can only calculate scalars, not vectors. And if you have a vector unknown, you should use Newton's second law. And when in doubt, you can always use both and figure it out as you go.